Hello, I'm Lynn Bondurant, your host for our series, 25 Years of Progress. During this 13-part series, we see some of the highlights of NASA, the National Aeronautics and Space Administration, since its official founding on October 1, 1958. What is happening in other American science and medicine the year before NASA is born? Well, 1957 is the year the American Cancer Society reports a high correlation between cigarette smoking and lung cancer. And new element nobelium-102 is disclosed by the Argonne National Laboratory in Lamont, Illinois. Overseas, on October 4, 1957, the Soviet Union launches Sputnik 1, the first artificial satellite. The Soviets' launch is for the International Geophysical Year, or IGY. The geophysical year is 18 months, from July 1957 to December 1958. More than 70 nations and as many as 30,000 scientists cooperate to investigate the world and its environment. Sputnik 1 concerns Americans because of far-reaching military and technical implications of the launch. Less than a month after the first Sputnik, the Russians launch a second Sputnik, which weighs about ½ a ton and carries a dog as a passenger. The second Sputnik causes even more concern in America because of the large size of the satellite. During IGY, the United States plans to launch a Vanguard satellite, which weighs just a little over 3 pounds. The attempt to launch the Vanguard on December 6, 1957, ends in failure in a ball of flame and wreckage. Keith Glennan is the first administrator of NASA. He is asked why NASA was formed.
That's a fairly easy question to answer. Sputnik. On October 4th, 1957, as I recall it, the Russians launched a fairly heavy object into orbit, and that caught us really by surprise. The Vanguard project had gotten underway in 1955, as I recall it, part of the IGY program, International Geophysical Year program, but it wasn't anywhere near ready. They had, I think, scheduled some launches late that year, that is in 1958, but it wasn't clear that they were going to be able to fly them. There was another competitor which had really never been recognized, and that was the Army with their Jupiter, which together with some upper stage solid rockets developed by the Jet Propulsion Laboratory in California, finally was the vehicle which launched a satellite for the U.S. early in 1959.
And the satellite was called Explorer 1. Let's go back to after Sputnik's success and Vanguard's spectacular failure. when Major General John Medeiros and Dr. Wernher von Braun and their team at the Army Redstone Arsenal are given their long-sought chance, a go-ahead to launch an American satellite. They will use their flight-proven Jupiter-C rocket launcher. We are at Cape Canaveral in late January 1958 as the covered satellite is placed atop the Jupiter-C poised on pad 26 for firing. Explorer 1 is to be about 30 pounds in orbit. Severe winds aloft force a 2-day postponement. Then on January 31st, 1958, the United States answers the Soviet challenge in space. Explorer makes a major discovery, a radiation belt around the Earth. Dr. James Van Allen of the University of Iowa identifies the region. The discovery of the Van Allen belt is an important finding of the International Geophysical Year. During a satellite television program broadcast in 1978, Dr. Ernst Stuhlinger, Director of Science for Dr. Wernher von Braun, makes this statement about the launch of Explorer 1.
It was a gate that opened into a new land. We hoped at that time that we will make progress and achieve many more things in space beyond launching a small satellite. I want to be honest though and say that at that time we did even not think it possible that 20 years later there may have been 12 men walking on the moon and coming back to Earth in good shape. Many of the dreams which we had at that time were fulfilled, but many other dreams which many achievements were accomplished which we even did not dare to dream at that time. However, when we look forward now toward the next 20 years, I have the feeling that the best is yet to come.
The United States space effort before the launch of Explorer 1 is fragmented. Navy, Army, Air Force, National Science Academy, and NACA. President Eisenhower appoints James Killian to be science advisor just after the first Sputnik launch. Keith Glennan recollects the writing of the Space Act which forms NASA.
My recollection would be that Mr. Killian, who was the President's science advisor, had been appointed almost immediately following the launch of Sputnik, and PSAC, the President's Science Advisory Committee, and I suspect Mr. Lyndon Johnson on the Hill did a sort of a cooperative job in putting together the Space Act. They had as a model the Atomic Energy Act. And indeed, if you compare the two, you find a good deal of similarity in many of the clauses in the two acts.
I see. Well, what were the major implications of the Space Act?
They simply said that we were to pursue the development of activities in space for the benefit of all mankind. We were to do it as a civilian agency. We were to be responsive to the military in the sense that if we found in our developments some gadgets, some information that would be of value to the military, we are bound to give it to them. And that was really the thrust of this act. We were also told that we should pursue international activities. And this is, I think, an extension of this for the benefit of all mankind.
The Space Act is signed into law by President Eisenhower on July 29, 1958, and on October 1, 1958, NASA comes into being. Glennan recalls Eisenhower's feelings about space.
He was not a space cadet. He used to say, as he looked over his shoulder and he'd say, you know, Keith, that moon's been there a long time. It's going to be there a great many eons yet. And we'll get there one day, but it isn't necessary we break our necks and break the budget to get there now.
Okay, what about congressional support at the time?
Congressional support was really very good. As a matter of fact, they were pushing us. I don't think in my 20 months there that I ever had a budget proposed to them that they didn't want to add something to. My stock answer was, I have studied this, we have presented you with a budget which is what we think we can usefully use. If we need any more, you may be certain I'll come right back to you. That seemed to satisfy them.
Before NASA is born, Keith Glennan is president of Case Institute of Technology and former commissioner of the Atomic Energy Commission. Then Eisenhower nominates him to be first NASA administrator in August 1958 with Dr. Hugh Dryden as deputy. And NASA is formed from the National Advisory Committee for Aeronautics. Glennan explains.
And we did inherit the National Advisory Committee for Aeronautics operation, NACA as it was then called, of which Lewis Laboratories was one. There were 4 or 5 such laboratories, 3 big ones, Ames, Langley, and Lewis, and one at Wallops Island in Virginia and one out in Edwards Air Force Base in California. But we had 8,000 well-trained, loyal, dedicated people in NACA, and they formed the base on which we erected NASA. So we were very well endowed.
NACA was formed in 1915 to supervise and direct the scientific study of the problems of flight with a view to their practical solution. NACA was required to direct and conduct research and experiments in aeronautics. The committee was responsible for many of the advances in U.S. aviation through 1958. Some space-type research is done in later years, but emphasis was on airplane research. Again, Glennan tells us what happened in NACA Space Research.
NACA had been doing development work, largely at Langley, as I recall it, on the shape of the capsule that might be used in an up and down flight like actually Mercury started out to be, and finally into an orbit. The problems of trying to get adequately capable people in a variety of fields meant that we had to look other than in NACA, and it became apparent very early on that our real limitation was in the launch vehicle business, the booster rocket, as we then called it. We really didn't have any. We had been using sounding rockets, small things that went up and accumulated information and telemetered it back to the ground, but we didn't have anything that really would lift very much with any degree of surety. So I guess it was probably in November, might have been late October of 1958, that I made a trip to Huntsville with Hugh Dryden, my deputy, and one of the very, very great men in this space program. His name cannot and will not ever be forgotten. We came back. It was clear that von Braun had a real strong team there, very capable. We did try to get that laboratory, or part of it. I didn't want the whole thing. They had work going on for the Army. The Pershing missile was in development at the time. And they had as their really scientific support the Jet Propulsion Laboratory managed by the Caltech out on the West Coast near Pasadena.
Dr. Glennan is successful in his effort to continue the job of building the new NASA organization. Officials transferred JPL, the Jet Propulsion Laboratory in Pasadena, to NASA, and the role of the California Institute of Technology as JPL manager continues. About a year later, officials transfer a large segment of the Army operation at Huntsville to NASA, and workers build it into the Marshall Space Flight Center. Only a week after NASA comes to life, Dr. Glennan approves the first U.S. manned spaceflight program, Project Mercury. Scientists developed the Mercury capsule shape through tests. Workers do wind tunnel tests of small and large-scale models, covering speeds from 0 to 18,000 miles per hour. Researchers fire small models of the capsule in a supersonic pre-flight ballistic gun range. The gun sends the 1-inch model down a 30-foot instrumented range of recording stations. The model goes 10,000 miles per hour. As the model speeds down the gun range barrel, photographs and shadowgraphs are taken. This shadowgraph shows airflow around the model. Workers developed boilerplate versions of the Mercury capsules for tests. This first test is a parachute drop test from an Air Force C-130. The capsule slides out of the plane's cargo door on a sled. The sled releases. A charge ejects a drogue parachute. Not only is NASA working on manned space travel, but from early on, scientists launched space science probes. Workers launched the Pioneer 1 probe toward the moon, about a week after NASA comes into being. A lunar TV scanner is aboard. Because of an error in burnout velocity, the probe does not reach the moon, but reaches an altitude of almost 71,000 miles, and the craft re-enters the Earth's atmosphere over the South Pacific on October 12, 1958. Glennan remembers that first Pioneer.
I guess we sort of broke our pick on some of those. I recall those were the Pioneers, as I recall it. And I recall how overjoyed we were when we could talk to that little bit of a thing. It's about this big. So fashioned. 200,000 miles out in space and get the information back. It never did reach the moon or go into orbit around the moon. It failed and fell back to Earth. But at the same time, the Soviets could never talk to their birds more than 10,000 miles up. So we were beginning to get a little sense that we were doing things right, that we were getting better all the time. And that was indeed the objective of NASA in those days. Push the state of the art as hard as you could, but don't waste your muscle.
The United States tries 37 satellite launches by December 1959. Less than a third are successful. As a result, NASA begins to instill a new sense of rigid quality control to check and check and check again rocket components, wells, valves, pumps, materials, and so on. Over time, the quality control program works. In other areas of science and engineering, the first domestic jet airline service begins between New York and Miami on December 10, 1958. And in August 1959, plans to explore Antarctica in 1959 and 1960 are announced. In September 1959, Severo Ochoa and Arthur Kornberg received the Nobel Prize in Medicine for chemical heredity work. Meanwhile, the first 7 U.S. astronauts are chosen. Early in 1959, NASA selects a team of 7 engineer pilots for Project Mercury. M. Scott Carpenter, L. Gordon Cooper, John Glenn, Virgil Grissom, Walter Schirra, Alan Shepard, and Donald Slayton. The astronauts prepare for flight. After 2 hours, the astronaut comes out of a mold used to make a flight couch to fit his body shape. Early on, veteran test pilots look down on the role of the pilot in Project Mercury, but the Mercury pilot plays an active role. He controls the capsule's attitude and pitch, roll, and yaw, as well as operating navigation and communication systems. In all Mercury flights, the pilot proves to be essential to the success of the mission. He operates all primary flight controls and initiates retro rockets to fire, beginning the descent to a landing. Whirling in a centrifuge cab, astronauts learn important lessons about how they react to the G-loads of emergency aborts. Meanwhile, workers test an escape system for the early Mercury capsule. The pilot must be able to escape from the Mercury launch site in case of an emergency. In this unmanned test, a 16-foot tower with a solid rocket sends the capsule safely away. During this test, a rhesus monkey is aboard. At more than 1,300 miles per hour, pressure sensing devices start the escape. Extensive Mercury program research and development continues. Workers launch a Big Joe Mercury test capsule nearly into orbit to test re-entry into the Earth's atmosphere. An Atlas booster carries the capsule to an altitude of 100 miles and nearly to orbital speed. From the recovery ships, the capsule appears as a flaming fireball as it streaks back into the atmosphere. Patrol aircraft fly to the impact area and pick up the capsule's recovery signals. 2 destroyers race to the area. The Navy ship Strong makes the pickup. The capsule survives its re-entry in excellent condition. Other areas of the space program are successful in 1959. By August, 10 of the 17 launches are good.
Please clear the launching area.
Also in August, NASA launches an Explorer 6, which functions well in all respects. Explorer 6 detects a large ring of electrical current circulating the Earth. During this first program of our 13-part series, we've seen how the launch of Sputnik in late 1957 encouraged the birth of NASA in October 1958. Early NASA projects continue through 1959. Lessons learned from early difficulties lead us to ever more successful performance. Next program, we pick up the NASA saga in 1960 when goals are still being set. I'm Lynn Bondurant.
Mercury capsule, go. All pre-start panel lights are correct. The ready light is on. Eject Mercury umbilical. Oil evacuate. Mercury umbilical clear. Mercury evacuate. Lights on.
Roger, Columbia on a roll. Columbia, Houston, you're go at 40.
Roger, go at 40.
Hello, I'm Lynn Bondurant, your host of our series 25 Years of Progress. During this second program, we cover 1960 and 1961 National Aeronautics and Space Administration projects. To set the perspective against other scientific and medical U.S. history in 1960, the Navy submerges a bathyscaphe to a record 24,000 feet in the Pacific Ocean. And in May, the U.S. atomic submarine Triton travels submerged around the world in 84 days. A NASA highlight is the launch of the first U.S. weather satellite on April 1, 1960. Called Tiros 1, it produces almost 23,000 pictures of Earth's weather. This Tiros 1 experimental weather satellite provides dramatic pictures of cloud formations, including spiral formations associated with large area storms. Tiros 1 works in a useful manner for 78 days. It's the world's first successful weather satellite. And ever since then, weather satellites help in weather prediction. Save lives and property through storm detection. Meanwhile, in the manned program, astronauts continue training for their space flights in the Mercury capsule. Astronauts practice with a spaceflight simulator at Lewis Research Center in Cleveland. Strapped firmly, the astronaut spins around first one and then all three axes. They do exercises in bringing spacecraft under control. A spacecraft in orbit travels at a speed which balances very delicately the pull of Earth's gravity. To simulate weightlessness in space, a pilot flies an airplane. The plane descends, begins a steep climb. As the aircraft decelerates, it eases over the top in a parabolic arc. For short periods, its occupants are weightless. Another first for NASA is the launch of Echo 1, the first passive communications satellite. Workers launch it into orbit on August 12, 1960. Echo 1 is really a big balloon. From it, radio signals are bounced, relaying signals between distant locations on Earth. Millions on Earth see Echo as a moving pinpoint of light in the night sky. T. Keith Glennan, NASA's first administrator, recalls.
Echo was a 100-foot in diameter inflatable balloon which was encased perhaps in an aluminum casing of about, I suppose, 30 inches in diameter perhaps. And it was, that case was exploded open when it reached a particular height. And then the balloon inflated. And it stayed up there, just circling the Earth as a matter of what we call injection velocity, when it was injected into orbit. And I can recall going up to Holmes in old New Jersey where they had a new type of antenna, a horn antenna. You now see them on towers around the country. And we talked to the satellite and we set pictures over that satellite. I still have one on my desk.
Echo is just the first of many communications satellites. Later communications satellites are much more complicated. They are active, not passive, carry antennas, receivers, transmitters, and other equipment. Modern satellites receive signals transmitted up from Earth and retransmit an amplified signal to distant locations. News, sports, entertainment television, telephone, facsimile, and other communications are now routinely transmitted via satellite. Satellites began a communications revolution. And 1961 is a year of other scientific advances as well. The National Geographic Society announces that the fossilized skull of an early humanoid discovered by Dr. Louis Leakey is 1.7 million years old. Jack Kirby of Texas Instruments invents the integrated circuit. On April 12, 1961, Soviet cosmonaut Yuri Gagarin becomes the first human being to orbit the Earth. His Vostok 1 spacecraft makes one orbit. Gagarin lands safely. Again, the Soviet Union accomplishes a first while the U.S. is preparing for a suborbital Mercury manned space flight. The Mercury ground tracking network includes 18 stations. Bermuda Station continues undergoing inter-systems checkout. Bermuda duplicates the control center on the mainland. Workers complete and ready the station for operation during April 1961. Other workers complete the final two stations, Kano, Nigeria, and Zanzibar. Scientists simulate orbital flights for training. During 1961, this unmanned test shot is ready for blastoff. The launch fails, but the escape system works, raising confidence for later manned flights.
I think the one thing that strikes me as I look back on the training program is that I have really developed a feeling of confidence. A confidence in the people with whom I work, a confidence in the systems with which I am dealing and will have to deal in flight, and of course, a confidence in myself.
In May 1961, astronaut Alan Shepard prepares for the first U.S. manned spaceflight with a Mercury capsule. The craft is to rise over 100 miles into space in this suborbital flight. Officials schedule the launch for the early morning of May 2, 1961. Weather postpones the launch.
Okay, ready to resume the count? Roger, ready to resume the count?
On May 5, Shepard goes to the launch complex. It is just 2 years and 7 months after the start of Project Mercury. As countless millions watch and listen, the astronaut manually controls his craft and has almost continuous communications with Earth.
On the periscope, what a beautiful view. Cloud cover over Florida, 3 to 4 tenths near the eastern coast.
The Mercury Redstone 3 travels 300 miles and reaches an altitude of 115 miles. Shepard enjoys about 5 minutes of weightlessness.
Condition is still good. I'm getting ready for impact.
About 16 minutes after liftoff, the spacecraft is found. A helicopter picks up Shepard and then his Freedom 7 spacecraft. The Mercury suborbital flight is a success, but the Russian Gagarin has orbited the Earth and in a heavier spacecraft. President Kennedy says, quote, "We are behind. The news will be worse before it is better, and it will be some time before we catch up." President Kennedy asked Vice President Lyndon Johnson to head a study of what is needed to beat the Soviets in the space race. NASA's 10-year plan calls for a manned orbital flight around the moon. The question is, can the U.S. be the first nation to orbit a man around the moon? The technical answer is maybe not. So the proposal is made that the goal be extended to the surface of the moon. On May 25, 1961, President Kennedy speaks before a joint session of Congress to define a new national goal.
Now it is time to take longer strides, time for a great new American enterprise. Time for this nation to take a clearly leading role in space achievement, which in many ways may hold the key to our future on Earth. I believe that this nation should commit itself to achieving the goal, before this decade is out, of landing a man on the moon and returning him safely to the Earth. No single space project in this period will be more impressive to mankind or more important for the long-range exploration of space.
As one author writes, NASA is exhilarated but awed. To land a man on the moon and return him to Earth is perhaps the hardest technical project in the nation's history. The Mercury project to orbit a manned spacecraft around the Earth is, by itself, a demanding program. But facing the challenge, NASA begins to work towards the assigned national goal. NASA decides that a two-man Earth orbital spacecraft called Gemini must be developed as a step between the one-man Mercury capsule and the Apollo craft, which is destined to fly men to the moon and back. Project Gemini is to learn of man's capabilities during longer periods of weightlessness, and Gemini is to help train astronauts to maneuver and rendezvous spacecraft during flight. The two-man spacecraft continues under design. Acquisition of the Titan II rocket for Gemini from the Air Force begins. Gemini is the intermediate project between Earth orbital and manned lunar spaceflights. By October 1961, NASA is already receiving proposals for a three-man spacecraft for moon missions. Officials evaluate proposals. Engineers and scientists of Project Apollo meet with industry people to discuss design and building of the Apollo craft. Companies present their models. On November 29th, officials select the North American Aviation Corporation of Downey, California, to be the prime contractor to produce Apollo spacecraft. During 1961, NASA puts 4 successful unmanned scientific satellites in orbit. Other NASA satellites are only partly successful. There are 2 good orbital tests of the Mercury capsule without a man on board. One of the flights carries a chimpanzee, and there are 2 manned suborbital missions, including Shepard's flight. Workers launch Explorer 10, March 25, 1961. The 79-pound satellite gathers facts about solar wind, Earth's magnetic field, and its reaction to solar flares. In April 1961, NASA launches the 82-pound Explorer 11. It detects gamma rays from cosmic sources and maps their locations in the sky. This is the first try of that kind of satellite space astronomy. Scientists and engineers put another successful Tiros weather satellite in orbit. And in August 1961, NASA launches the Explorer 12 satellite into a highly elliptical Earth orbit. Explorer 12 investigates solar wind, interplanetary magnetic fields, energetic particles, and the Van Allen belt. The second manned suborbital U.S. spaceflight with astronaut Virgil Grissom aboard is a success, but the spacecraft is to sink in the ocean. Grissom experiences 1.5 Gs. The flight surgeon closely watches the test pilot's condition during flight. Grissom's vital signs are okay. At engine cutoff, the spacecraft makes its turnaround and the astronaut is weightless. The retrieval helicopters are within 2 miles of the landing point. Grissom says he's ready for pickup. As the lead helicopter moves in to hook the capsule, the side hatch is blown off. Grissom leaves the rapidly filling spacecraft. The recovery helicopter struggles with the almost submerged craft. The helicopter is overtaxed by 1,000 pounds. A second recovery helicopter moves in to pick up the astronaut. Grissom has trouble staying afloat. After 4 anxious minutes, Grissom struggles into the horse collar. The lead helicopter's motor apparently malfunctions. The spacecraft drops. Project Mercury continues in high gear, pointing toward a manned orbital mission. On September 13, NASA puts an unmanned Mercury into orbit. One test objective is met early in flight. The Atlas releases the spacecraft into proper orbit. 1 hour and 49 minutes after launch, the spacecraft lands 200 miles east of Bermuda. Enos, the chimpanzee, makes a Mercury flight in November 1961. The chimpanzee arrives at Cape Canaveral from Holloman Air Force Base. Workers put the chimp in a special couch with testers and a pallet and water feeder. He is 39 pounds. During pre-launch testing, Enos is connected to the spacecraft's environmental system. Fitted with numerous biosensors, the primate does tests. Later, NASA launches Mercury with Enos aboard. About an hour into the flight, the spacecraft passes over Mouchet, Australia. Then 5 minutes later, the Woomera, Australia tracking station confirms that all systems are green. A 16-millimeter camera gives a periscope eye view of the cloud formations and the island-dotted Pacific on a condensed time film. Going into the second orbit, tracking stations report steadily rising spacecraft temperatures. Midway through the first leg of the second orbit, Kano, Nigeria reports the spacecraft is reporting intermittent roll and ignore signals. A slight rise in the chimp's temperature concerns flight surgeons. Officials decide not to fly the spacecraft into a third orbit, and they order retrofire. The descent, landing, and recovery are all normal. That afternoon, at a press conference held at Cape Canaveral, NASA officials say that they are pleased with the flight. Astronaut John Glenn is test pilot for the upcoming first manned orbital Mercury mission. Astronaut Carpenter is backup. 1961 is coming to a close, and Enos, the spacefaring chimp, returns triumphantly in December to the Cape. Meanwhile, the Mercury capsule undergoes further tests. There are 2 water landing tests in December 1961. And so 1961 ends, and in that year NASA begins to work on the big job of sending men to the moon and back.
Roger, 0G, and I feel fine. Capsule is turning
During our
around.
next episode, we see film of John Glenn making the first U.S. spaceflight around the world in 1962. And we continue the saga of NASA during 25 years of progress. I'm Lynn Bondurant.
Roger, Columbia, on a roll. Columbia, Houston, your go at 40.